Good morning, students. This is Miss Cole. Remember how we talked about our math unit, that we were going to talk about triangles and we were going to review our fractions? Well, I'm going to have you review it using Geogebra. We've used that a couple times before, and we're going to talk, your group, on this section. I know you're rotating around the room. We're going to talk about different kinds of triangles. So you all should have this worksheet here. What are the different kinds of triangles? Each member in your group should have one, and as it says in our directions, remember you only need to submit one of these record sheets per group. So make sure everyone's taking notes and filling out the sheet, because I will be checking for completion on everyone, but I only need one to grade. Alright, so let's review what we're supposed to be doing. It says, create each of the following 6 triangles using the Geogebra activity and answer the questions about them. Now, since we're using our computers in the classroom today and we're rotating around the room, I have the web pages pulled up on the computer. It should be pulled up on yours right now. If it's not, pause the video here and raise your hand quietly and I'll come over and help you, okay? So, let's look at Geogebra first. This is where you'll be working. You have a triangle here, and the directions say at the top, drag a point C and create the different kinds of triangles: scalene, acute, isosceles, obtuse, equilateral, and right. Now I know we've only talked about this a little bit in our class, but you're going to be experimenting by pulling this point C around. Alright, so our first one, let's look back at our worksheet real quick, is to create a scalene triangle. Okay, I'm going to be going through the first one and typing in the answers here, but after that, each one as I go through, you'll be expected to write down yourself. So we're going to create a scalene triangle. Oh, did anybody see that? See, this is all you do. You just pull point C around and you see how these change, okay? So, look, we created a scalene triangle just by moving it around just a little bit. So let's look at this. It says, from its sides, the triangle seems from its sides to be scalene. Now here, it says that a scalene has no equal sides. So let's go back over to our worksheet, and we created a scalene triangle, and it says, are the sides equal? And it told us that a scalene has no equal sides. So we would say, no, a scalene triangle has no equal sides. And then the next question is, are the angles equal? So let's go back. This triangle seems from its angles to be acute. 3 acute angles. Now, acute doesn't necessarily mean that they're equal or not. Acute, remember, means if it's less than 90 degrees, it's an acute angle. So look at all 3 of our angles. 60, 80, 39 degrees. Now, here your angles may vary. Although you have no equal sides, it might be possible to have 1 or 2 angles the same. But in our case, all of our angles are different, as you can see. We have a 60-degree angle, an 80-degree angle, a 39-degree angle, but they are all acute. So when we go over here, we're going to say, no, the angles are not equal. They are acute, though. Okay? Now, those angles we're going to worry about down here because it asks us what is the measure of the angle, so we'll fill that in just a minute. The next question is, what are the lengths of the sides? Now we know, of course, a triangle has 3 sides, so we're going to have 3 numbers to write down here. Your sides are here, and then these bigger numbers are the length of the sides. So we have one side that is 3.6, 5.7, and 5. We don't need to worry about units here just because we're on the computer, and of course it's not to scale. We could imagine just by looking at this that maybe it's centimeters or using our previous background knowledge. So we have 3.6, 5.7, and 5. So it is 3.6, 5.7, and 5. You can write it down just like that. And then what is the measure of the angles is next. So do the same thing, 60 degrees, 80 degrees, 39 degrees. Now, to save you some time, I'm not going to put in the degree symbol, which is, of course, this one here. But I do want you all to write that in with your pencil, okay? Make sure you write degrees. You will have points taken off if you don't have it. And then finally it says draw a picture of what your triangle looks like. Now again, I'm on the computer, so I want you all to take the effort to draw out this triangle. When you're drawing it, try to copy it exactly how it looks. We have, this is our shortest side, this is our longest side, and this is our side in the middle. And then I want you to write in the measurements. Let me add that direction here. Write in the measurements of the angles and the sides. Make sure you do that for each one, okay? So, like I said, I did the first one for you. I wrote it in and I showed you how I would like you to put it in there. Now, as I go through, I just want you all to write in by yourselves. So, the next one we have is an acute triangle. We know that the angles are acute, but we're looking at creating a triangle that is from its sides that's acute. So we're going to move it around a little bit. I'm doing this because I don't necessarily just want to show you what it is. See, that's another scalene triangle, but with obtuse angles, just to show you a different example. Now, you've seen me moving this around a lot, and I'm not getting an acute from its sides. So, this makes you think. Can you have an acute triangle from the sides? No. If you recall in our brief discussion, we did talk about that. An acute angle an acute triangle, can only be formed using the angles. So look here, I created a scalene triangle that was also acute. The first triangle that we created was also an acute triangle, okay? So you can use the measurements from the first triangle to talk about it, or you can use the measurements from this triangle. I also want to show you, there is a triangle you will create later, but I'm not going to tell you the name of it now. You might already know, and that's okay. But look here. This triangle has equal sides, so it's not scalene. It's what we call this word right here. Again, I'm not going to say it yet. But it's also acute. It has equal sides, but it has acute angles. You can use this one if you want as well. I'm going to leave this up here and give you a minute to write things down. You can pause the video if you need to write down your measurements. Okay, so after an acute triangle is going to be an isosceles triangle. So for our isosceles triangle, I'm going to move things around, and I want you to notice that when you see isosceles, is it a sides classification or is it on an angles classification? Oh, there we go. What do you notice here? It's on the sides classification. So isosceles triangles are categorized by two equal sides, 3.7 over here and 3.7 over here. And then you have 5 as the length of a side, which is different. Now, the angles are 3 different angles, 48 degrees, 85 degrees, and 47 degrees. But they are all acute. So we created another acute triangle, just like in the previous question. So, take your notes. You can, again, if you want on your paper, you can create your own triangles. I want you to be moving it around as we're going through this module. I want you to be manipulating the screen yourself, seeing how things are going. Okay, and once you have written those answers down, we'll move on to the next one, which is an obtuse triangle. An obtuse triangle, I want you to look again, whether it's angles or whether it's classified by its sides. I'm going to move it around. Oh, what does that say? That says obtuse from the angles. It says obtuse triangles have one obtuse angle. Now look here. 32 degrees is less than 90. 35 degrees is less than 90. 114 degrees is much more than 90. That's our obtuse angle. See how in this one I always describe it as it looks like a mouth opening up to swallow something whole? An obtuse angle is much bigger and makes the triangle look much wider than the others. You'll also notice that with an obtuse triangle, the side opposite that angle, so this one over here, has a length of 8, which is the largest. This always happens with an obtuse triangle, okay? Always remember that. So we also created a scalene triangle with no equal sides. Take that into mind too. So write down your measurements if you would like, or create a triangle of your own. Alright, so after you've written that down, again, you can pause if you need to. We'll move on to the next one, which is this word I was talking about earlier, an equilateral triangle. An equilateral triangle, watch me create it here, okay? It's going to take a little precision on my part, and you too, so practice. I'm going to make a big one. There we go. Equilateral, 3 equal sides, okay? 5, 5, and 5. All of our sides are the same length. And then I made it so that all of our angles were the same length. So we had our equilateral triangle. Remember we talked about that. If you needed to, you can pause and write down what we had there. But I'm going to quickly move on to the last, which is create a right triangle. I've already created it here. Notice how it says a right triangle has one right angle, which you can see here. We talked about how a right angle is 90 degrees. It has one right angle, two other angles that are of different measure. All three sides are different, so we have a scalene triangle as well. And so I want you to go ahead and write down the specifications for that and write down or draw your picture. And as soon as you finish that, you have completed our module and our worksheet. You're finished. Good job, group. Now, remember to turn in one of these record sheets to Miss Cole, me, and move on to the next module with your group. Okay? If you have any questions, remember to raise your hand and let me know. I'm so proud of you all for working hard, and I'm glad we get to use the computer as part of our lesson.